Okay, so lesson 1 started. We have 6 plus 7 root x over 2x cubed. So first thing to do, remember, is split them up. 6 over 2x cubed plus 7. I can write root x is x to the half over 2x cubed. 6 over 2 is 3. And then I've got no x's divided by x cubed. So 0 take away 3 is minus 3. Plus 7 over 2, x half, take away 3. Well, that's 6 over 2, so that's minus 5 over 2. Yeah, but what we can't do to begin with, we're not allowed to do 6 plus 7 root x times by 2x minus 3. We can't do that. If you want to take the one to the top, you can put the minus on the outside of it. That mathematically is correct. However, that 2 gets the minus as well, so you end up doing 6 plus 7 root x times a half times x to the minus 3. So you may as well just leave the 2 on the bottom of the fraction anyway. Okay, first one done. Second one, we have y equals e 3x sine 2x, and we know that x is between 0 and pi, and we want the stationary points of the x coordinates. So stationary point, the knowledge is dy by dx equals 0. Well, we've got a product here, so u we'll call e3x, v we'll call sine 2x. Differentiate that, you get 3e3x. Differentiate that, sine goes to cos, so it's 2 cos 2x. And then the rule, so the knowledge, again, if you need to know, is u v dash plus v u dash. So we get 2e3x cos 2x from these two, plus 3e3x sine 2x from these two, and we know that has to equal 0 because of that fact there. Well, I can factorize out an e3x, so 2 cos 2x plus 3 sine 2x, and that's 0. Well, I've got two brackets really. So either this equals 0, so e3x equals 0, which has no solutions because I can't do ln of 0, or this thing equals 0. Well, I've got a sine and the cos, so I can make a tan. So if I take the cos to the side, I get 3 sine 2x equals minus 2 cos 2x, divide by 3, and then divide by, so we're getting rid of the cos 2x and getting rid of the 3. So I get sine 2x over cos 2x equals minus 2 over 3. This bit here changes into tan 2x equals minus 2 over 3. Change the 2x into a different letter, so I'm just going to call it, it's called t, because I can't use y because I've got y up there. So tan t is minus 2/3, and t now goes between 0 and 2 pi. In radians, make sure you calculate this in radians. Do tan minus 1 of minus 2/3, and we get minus 4.588. And since it's tan, we can do pi plus the answer. So pi plus the answer gives us 2.553. And this one's not in the range, so I can add 2 pi to that and get 5.695. And that one does work. So these two, to get what x is, we just divide by 2. So 2.553 divided by 2. And let's give it to 3 significant figures. So 1.28. And then the other one, 5.695 divided by 2. 2.85. And remember, you can use solving to check they're right. So it's all working out for that one. Okay, next one is partial fractions. So we have x 2x cubed minus 1 over x squared plus 2x plus 1. It's an improper fraction, so that means I would have a constant, but the question tells you anyway. It's a plus b over x plus 1 plus c over x plus 1 squared. And that's because that's just x plus 1 squared if you factorize it. Okay, so times by this denominator here, which is just x plus 1 squared. Actually, let's change that. X plus 1 squared. So times by x plus 1 squared. So I get 2x squared minus 1 equals a x plus 1 squared plus b x plus 1, because x plus 1 will cancel out one of those, plus c. Okay, now we sub in our obvious numbers, but the first one is x is minus 1. Minus 1 squared is 1, times 2 is 2, take the 1 is 1. That disappears, that will disappear, and that's just c. So we have that 1 is c. Now, to get a and b, I could sub in two random numbers and get two simultaneous equations. So 0 and 1 would be good choices. However, if you can spot it, then if I divided this, I'll have 2x squared divided by 1x squared. So a should be 2. But I'm just going to show you the other method, just in case you don't get that. So sub in two random numbers at 0. So that would just give me minus 1 equals 1 squared is 1, so 1a. 1, so 1b plus 1. So a plus b is minus 2. Taking that 1 to that side. Take another random number, so 1. So 1 squared is 1, 2, take away 1 is 1. 1 and 1 is 2 squared, so that's 4a plus 2b plus 1. So that cancels out, the 1 and the 1 will cancel out. I can divide by 2, so I get 2a plus b is 0. Well, take them away. So a take with 2a is minus a, they cancel out. That's minus 2, so therefore a is 2, which I said it would be. Sub it back into one of them, so if I sub back into there, 2 add b is minus 2, so b must be minus 4. So a was 2, b was minus 4, and c was 1. Yeah, like I said, if you can spot how to get a quickly by doing that dividing trick, it would have saved you having to do simultaneous equations. I could just sub in x is a, x is 0, put a is 2 there, and I would have got b very quickly. Okay, fourth one. Find the x squared term of the expansion 3 plus px to the power 6 is 19440. So that goes to my x squared term. We want to find the two possible values of p. Well, to get the x squared term, I'll need 2 of these. So that means I'll need 4 of these. So that means my c would be, well, 6c, and I could either use 4 or 2, and we'll use 2. And that would equal 19440 x squared. Well, 6c2, 6 times 5, so that's 15 times 81 times p squared x squared equals 14440 x squared. Well, I can ignore the x squareds, and I can do 15 times 81 on my calculator. So 1215, I get p squared, it's 19440, and then divide by 1215, and we get 16. So p is plus or minus 4. Now, if you've got the squared p, you're going to get a big mistake. And the last one, for 5, we have a vector 4 minus 5c, and the magnitude is 10. And we want to find the exact values that c could be. Well, magnitude, remember, means square root of 4 squared, add 5 squared, add c squared. Remember, I can ignore the minus to my square root it turns positive. And we know that equals 10. Get rid of the square root by squaring the other side. So 16, you can do that in my head. 25, add c squared equals 100, 10 squared. So that gives me 41, add c squared equals 100. So c squared is 59. So c is plus or minus root 59.